Hello, and welcome to the Design Studio Keynote. Thank you, Brandy, for the lovely introductions. We run the Autodesk Design Studio product management team. Before we now going into the details of the presentation, let me show our safe harbor statement. We are talking about future developments, and as we know, the future can always change, so please do not take any buying decisions based on the content of this presentation. So today's presentation is going to be all about the value we deliver across the whole design process, from the very first idea up until engineering-ready outcomes. And there's one theme across all of it, and that's driving speed. When tools feel natural, when workflows are connected, when teams collaborate, when data flows, you move faster. And not just faster in terms of time, but faster with confidence. Today, it's all about compressed development cycles. There's intense pressure to reduce vehicle development time. But it's not only about the speed. It's about reducing cycle times without sacrificing quality. And the balance, speed and quality at the same time, is exactly where we focus. Whether it's AI-driven exploration, hybrid modeling, visualization, engineering insights, or platform APIs, it is all designed with one goal in mind, and that is accelerate your design process across a connected workflow from end to end. And yes, AI plays an important role in that story, but we're not doing AI just for the sake of it. We're using AI where it solves real problems: faster form finding, quicker storytelling, simplified modeling, earlier engineering insights, and the automation of repetitive tasks. So today's keynote is structured along the whole design journey: concept acceleration, how we're transforming surfacing, visualization and decision-making, and engineering insights. But this is not in silos. This is not sequential. It's really where the pieces connect. A studio that works in parallel, that works informed and in flow. When you are confident in the tools, the data, and the decisions, you move faster. So let's start where everything begins, with accelerating concept design, and handing it over to Timo.
Hello. So, designers need to explore quickly, without losing intent, proportions, or feasibility. So today, I'll show you how Alias is accelerating the journey from rough sketch to real geometry. We're introducing new capabilities across concept development workflows in Alias. New sketch-to-mesh and mesh rescaling workflows make early 3D more controllable. Multi-layer paint and AI image generation tools accelerate concept refinement and visual storytelling. And new retopo workflows dramatically simplify the transition from meshes to subdivision geometry. What's changing is the speed and continuity of concept development in Alias. Designers can now move from rough ideas to real geometry through a connected workflow for concept exploration, visualization, and surfacing. And because those workflows stay grounded in real design data, teams can make faster, more informed decisions earlier in the process. So let's get into it. With paint layers recently released, designers can mark up and brush out changes directly on a sketch. Layered visual editing turns concept refinement into an iterative workflow directly inside Alias. With Concept Assist, our new AI plugin, designers can turn marked up sketches into photoreal images in seconds. Once you land on a promising direction, Concept Assist can generate consistent views of multiple perspectives. That consistency is what enables controllable 3D generation. Form Explorer converts those images into 3D meshes. Using up to 4 aligned views, designers can generate meshes that are pre-processed for downstream subdivision workflows. That enables the creation of concept variations, many concept variations, in minutes. Designers can also generate supporting 3D assets isolate mesh regions and quickly apply material variations using alias subset controls and VRED materials. And the result of that is faster concept refinement with stronger concept presentations. Designers can use Concept Assist to rapidly explore adjacent vehicle categories while preserving design language. Paint layers keeps visual edits aligned directly to the active design view. Designers can quickly explore different refinements of a concept, then feed those edits directly back into Concept Assist to generate new variations. This creates a fast feedback loop between editing, visualization, and concept evolution. Using Concept Assist to place concepts into contextual scenes that communicate design intent and emotional direction instantly, designers can quickly create compelling visual stories directly inside Alias. This brings AI storytelling into a connected concept design workflow. Form Explorer lets designers guide image-to-mesh generation by defining a single exterior dimensional constraint. That helps keep geometry aligned with real-world proportions from the start. Using Transformer Rig, designers can quickly correct proportion drift introduced during AI generation or mesh scanning. This enables concept to stay aligned to package constraints while preserving original intent. This also allows teams to iterate quickly and stay grounded in real-world feasibility. Alias Retopo now has a region selector that dramatically accelerates mesh to subdivision workflows. Designers can now convert and refine surfaces region by region, whether the source is scanned data or AI-generated geometry. We're seeing workflows in this domain accelerated up to 10 times. So, AI is not replacing designers. AI is compressing the distance between ideation and real geometry. We're removing friction across the concept development process so designers can explore more directions, make decisions faster, and stay grounded in real-world constraints. From sketching to services, grounded, connected, and real inside Alias. I'll hand it over to Brandon. Thank you. Cheers.
So obviously, a lot of things are changing. But this isn't the first time that we've seen change. I think we've all been through it together, and we know we're going to go through it together again. And I just want to stop and pause and say thank you to all of you who have depended on us for so long. We want to continue to be your dependent partner. We want to continue to be your trusted partner. And we want to continue building out tools and capabilities that solve your problems every day. At the core, we believe Alias's hybrid modeling capabilities are one of the most valuable things that we provide for you, allowing you to explore quickly, refine to the highest quality, and know that what you design can be built. We're going to continue investing in all of that legacy, that we can continue to live on as your trusted partner for the future. So today, I'm going to talk about how we are building forward our future for Alias and the high-quality design and surfacing capabilities that it provides. I'm going to start talking about continuous design and exploration. This is how we help you explore, refine, and define your work without having to constantly rebuild it. Next, I'll talk about always production ready, making sure all these ideas and concepts you explore can be brought up to the highest surfacing quality possible. So you can hand that off to engineering nice and easily. And lastly, we'll talk about data prep automation. Two words that go really well together, data prep and automation. Really helping you automate all of the things that you don't want to do on a day-to-day basis, speeding up and allowing you to focus on the creative work, the stuff that is more fun and exciting, and why you are also valuable. So let's begin. Picture this. Your surface data is coming together, but your design manager has asked for a change on the hood. Instead of designing, you're now shifting topology and adding more information that you just really don't want to, and you've spent all afternoon. We're hoping to fix that. The video you're about to see is called Variable Crease. Instead of adding a bunch of extra geometry and locking in more detail, you now can select edges, slide a value, and change the radius non-destructively. This used to take a modeler, all afternoon. This can now happen in a couple seconds. And because this is Alias, our output is an actual limit surface, not just a mesh. That means this data can go directly to engineering. So this is one way. We're trying to keep you flexible, capable, and helping you with hybrid modeling capabilities in Alias. Next, let's talk about how you take in data. So as you saw in previous examples, generating meshes concepts in AI. But also, we know you take a lot of scan data in from the Clay teams. We know around the world, Clay is also still a very important part of the automotive design process. But very often, your job is to get that scan data back and make it reusable. So how are we helping do that? Powerful tools like sub-D retopo and Alias lets your teams take that incoming geometry, restructure it into clean production quality control cage without having to start over. This removes a huge manual step, gives you flexibility to iterate more often, from digital to physical, back to digital again, and go through that cycle many, many times. We want to make sure that no matter where your geometry starts, Alias is going to help you to really make that into a workable state quickly. But continuous design is not just about having the capabilities to review and refine quickly. When your team is ready to step into review, we continue to support you, making all sorts of decisions across your process. Decisions are speed, and the tools you do that are now more accessible than ever. Immersive, full-scale modeling and surfacing reviews can now happen sooner in the process with View in VR and View in XR inside of Alias starting in 2027. So we've overhauled this experience, provided an improved UI, and a user experience that maps directly to VRED, that allows you to leverage the latest and most high-quality headsets to make sure you have the tools you need to do your jobs. But also gives people context throughout the day about what they need to design, how they can refine, and how to take every iteration further every single day. This saves time in data prep, but also simultaneously helps you push the quality of your design by more constant iteration. So another way that we're helping you save time and push the quality of your designs. But let's talk next about how or what happens when exploration ends and refinement begins. Going from a strong concept sub-D model to engineering Class A services is a process that can take many months and a lot of time from very senior and important people. We've heard loud and clear from a lot of you, you want to save a lot of time here, and you're looking for us to help you do that. So we are currently researching and investigating more advanced ways to refine and optimize services, some that I want to show you in the next couple slides. Let's start with Surface Combined. The thing I'm about to show you allows modelers to create large, production-quality NURB surfaces directly on top of sub-D geometry. The kind of clean slabs engineering teams like to receive. But because they're live, these sub-Ds can continue to change, and the NURBs will update with it. Your modeler doesn't need to lose hours because engineering's asked for a small adjustment, because this connection gets maintained through history, meaning that you can continue working with sub-D surfaces all throughout your vehicle production process. This is just another way that we're looking to support you throughout design, concept, into higher quality Class A surfacing. But even with the right geometry in place, getting Class A quality is extremely time-consuming. We know that. That last 10% of surface refinement can take up to 90% of the time. And sometimes it may be impossible to reach that continuity that you desire. So that's why we're researching topics around surface or CV optimization. We're exploring how we can use machine learning, advanced algorithms that can really help you automate and save time in that last 10% of time. So let's look at an example of this. This is something we call CV optimization. This first example is a surface that may be too complex or time-consuming for somebody to ever do. We're finding a way to optimize the CVs on this geometry and make it really good quality. This next example is a more, I'm going to say, classical way, a more common use case, where we can optimize two blends simultaneously. We can take these optimization tasks that take many minutes or even maybe hours or not possible by a human to do and resolve these in a matter of seconds. Compounded across a whole team and a full vehicle program, there's a lot of time savings to be had here by improving quality and saving you time while you do it. Next, I want to talk about high-quality data prep and automation. So, how do you continue to produce high-quality designs in less time? You manage the process. Managing data, preparing it, having trust in it is a lot of time and effort. I think we probably all know that. Honestly, the only way to really wrangle it is to start automating key parts of it. The more content you're going to be generating into the future means the more data and more pressure to manage the data is going to continue to happen. Whether that's managing design data itself, generated images or videos, now even scripts and plugins and tools. We are still using flow production tracking as the integrated way within Alias and VRED to manage a lot of the day-to-day data you create. That can be day-to-day files, data for review, and just having good transparency along the process. But what next? In the past couple years at AIF, you've seen some really cool stories around flow production tracking, and you're interested in how to build amazing things too. We realize it is still challenging to get started. So our teams right now are investigating ways to make deeper data management integrations into our applications, better ways to view and explore and visualize these as well. So if you're still interested in this topic, if you want to learn more about your process, how to manage it and organize it, please talk to our consulting team outside where they can go into some really good detail and learnings that they have across the whole world on this topic. But next, as one of the core foundations to support broader automation, I'm super happy to get to announce today that our teams are extending the Alias API and providing you a Python interface for it. I heard a gasp, I feel like. I think that was true. If that is true, thank you. That's awesome. While APIs have been around for a long time, especially our Alias API, it wasn't really accessible. So now, with a Python API, we can make things that were once thought impossible much easier accessible to all of you. In the world of AI, Python script creation is now becoming accessible to everyone, and it does it pretty good. So supporting Python and Alias is step one to really give you guys all control over your own destiny. So I'm about to show you a bunch of examples that our teams internally are building with this Python API. These are all part of a technical preview, so don't pay too much attention to the actual user experience, but focus on the outcome. Regardless, though, what I'm going to show you, I think, will change the way that you fundamentally work. So first, the API can solve many kind of simple problems, but also extremely painful problems. Let's look at a video of organizing your scene. This race car data set has parent groups sitting at the default layer, and they need to be cleaned up before release. We're using Python API to scan the default layer, find groups whose children all live on a single layer, and move those to the parent group. Restructuring the scene correctly, done quickly and automatically, are the kind of things you're looking for to speed up your process. But you can do more. This next example allows your users to easily unify normals. First, it groups surfaces together, uses your mouse clicks to quickly flip normals at a bigger component level, and then it helps you unify them across all of these big groups, rather than just individually surface by surface across your data set. Another great example of saving time. But there are so many more possibilities around this. Let's now show you an example of automatically stitching and meshing this data set. So our team's created a Python script that uses layers and materials to separate all the geometry. We combine all the surfaces of the materials into stitch data by part, and we can also generate mesh data along with that, so that all the material assignments stay intact. So if you saw at the beginning of that video, we started over here, and then we went to here in about 3 seconds. This is how we save you time on data preparation, things that you probably don't enjoy doing anyway. So currently, our API is actually quite good at data organization and data preparation. But at the moment, it's a little limited on the surfacing modeling type tools, but it doesn't have to be that way. As we develop the API further, we want to look more at the modeling tool space. So this is an example of multiple tools our team has put together into one tool that can utilize a bunch of underlying tools. In this example, it's crease, bevel, offset, creased edge, and then applying a variable crease. So all of this API stuff I'm showing you is a technical preview, but I hope you can see the power and potential of a Python API in Alias. And if you'd like to try it out, this will actually be available in a technical preview tomorrow. So look out, try it, and we're excited for any feedback you have about how to improve it for the future or what you're going to do with it. OK, so the API is truly foundational. This will be underpinning many things that we can do and support you to do in the future. But complementing our API story and also leveraging it, I'm also happy to announce Autodesk Assistant for both Alias and VRED. Autodesk Assistant is being made available across all Autodesk applications. And its goal for you is to help you learn and understand our tools better, guidance on common industry-specific workflows, provide technical support and troubleshooting, but also helping you execute similar commands, just like I shared examples in the API. So while you can use the API to do a lot of these things, in the future, you can also use Autodesk Assistant and using natural language to perform a lot of these simple tasks. So again, I'm going to show you some examples. We believe Assistant will be really good at doing simple things like cleaning up scenes, similarly to the API. I can ask Autodesk Assistant, how about take all the curves in this scene, put them on a new layer called curves. In this case, Autodesk Assistant will talk to Alias through the API, query the scene, create a group, and parent all the curves to a new group. Pretty cool, pretty easy. So that first example was quite simple, but let's take it a couple steps further. Some teams like to group or work on things by part or component. Other teams or people like to group things by material. Let's say you wanted to switch. In this case, let's ask Assistant, make new layers per shader, make all of those groups surfaces with those assigned shaders, and put them onto a corresponding layer for that. You'll see it process the request, and the short list of layers that I have on the left here will become a big, long list of layers based on all the material assignments. And if I toggle the visibility on those, you can see those surfaces have been correctly applied to those new layers it created. All right, one last example. So just like the last API example I already shared, we can ask Autodesk Assistant a similar question. For each shader, take all the surfaces with those assigned shaders, stitch those surfaces, put the stitch geo onto a new layer called stitches, and then take those surfaces, generate a mesh for them, put the output mesh, and a separate layer called meshes. That's quite the mouthful, but if you can write it, you're hoping Autodesk Assistant can help you do it. So if we run this Autodesk Assistant prompt on our scene, it's going to do a similar thing that you saw the API do. It's going to go through, going to get all of the different surfaces. It's going to generate the stitch data. It's going to put it on a new layer. And it's going to generate the mesh data and put that on a new layer. So with the support of the APIs, your teams will be able to use natural language to use Autodesk Assistant to integrate and really automate a lot of the common day-to-day tasks that many of your teams don't like doing every day, save you a lot of time, and really not have to have anybody write any code to do it. OK, so that wraps up my part. So today I shared how we are providing you innovative, fast-moving, and creative tools that support this continuous design workflow. with tools like variable, crease, retopo, and the view in VR and XR tools in Alias. In parallel, we're bringing you to production-level quality faster by making sure that we use tools like Surface Combine and CV optimizations to get you to the high-quality engineering handoffs that you need to do. And then we're giving you the power through workflow and process automation to automate lots of repetitive day-to-day tasks, leveraging the new API and Autodesk Assistant. So lastly, wherever your team is exploring, however you're defining your first forms and shapes, refining to Class A, preparing data, engineering handoff, we are hoping and we're focused on getting you to the highest quality designs faster than ever before. Good luck, buddy.
OK, so now that we know how to build the highest quality models faster, let's talk about how those models evolve and in which direction. Direction comes from information, and that information is what we are building, a layer that goes across the whole process. I tried to split it into 3 sections for the presentation today, and there's way more that our teams are working on, but we had to filter it to some. One is the visuals that win decisions, the one truth that the team can rely on, and the room where every stakeholder contributes. Because every great car is shaped in thousands of moments. A designer pitching an idea, a leader making a call, or an engineer flagging and hopefully resolving a constraint or an issue. We don't accelerate one of those moments, we want to accelerate all of them. And the first place we accelerate is the moment a design has to win. Either internally, a design team is pitching a theme or a design to leadership, or also externally when a marketing team is telling the launch story to customers. They're basically doing the same thing, or very similar, selling an idea, visualizing a vision, merging design intent with emotional intent so the audience doesn't just see the vehicle, they feel it. And that's where our AI-augmented visualization stack changes what's possible today. So in this example, a visualization artist starts with the VRED AI Image Assist, a controllable, iterative, production-grade toolset, and then prompts basically the scene that they envisioned. So the environment, the context you want to place your car into. It's getting more interesting in the next step, where we're taking this AI image and putting that into 3D, where Asset Assist builds a full 360-degree environment that you can freely move in, represented, as I said, or sourced from the initial idea or AI image. The artist navigates the scene in VRED and refines the camera angle and positions the vehicle exactly where the story needs it. That's the first step. In the second step, Asset Assist populates the scene with life. Whatever you can imagine. People, props, lifestyle details, placed where they belong. A family next to the truck, a campfire, a camping setup, in this example, luggage on the truck bed. All generated, all in 3D, all in the same scene. And this 3D scene becomes the reference that gives the artist precise control and consistency over what AI Image Assist outputs next. Because once the scene is ready, the artist fine-tunes the final prompt, using the same Image Assist controls to refine lighting, color grading, mood, you name it, and output a high-quality image consistent with their intent and without the AI touching the design of the actual vehicle. From the same 3D scene and prompt, you can easily generate supporting imagery. Just rotate the camera. You have the consistency through the 3D scene. You just regenerate based on the same prompt, different camera angle. And in the future, when the story is ready to be told, Video Assist will turn that scene into a finished video based on the same 3D reference and the motion described either in a prompt or in the VRED animation capability itself. And in an even further future, and we're seeing some steps toward that in the exhibition already, and of course we're working on that internally as well. As Gaussian splatting and other related technologies are becoming more and more, evolving more and more further and further and becoming more and more production grade, we are likely to reach a future where you can just put on a headset based off this AI-generated scene and experience it first person. If you want to learn more about those technology pieces that need to come together to realize this vision, make sure to join Pascal's deep dive presentation tomorrow afternoon. And the result is every team whose job is to sell a vision, design or marketing, internal or externally, gets emotionally compelling visualization at the speed the conversation demands. What you're watching on screen, every scene, every image, that's what our hybrid AI workflow produces in minutes or hours, where traditional pipelines needed weeks of specialist work to get the shot right. In addition to that, the vision doesn't get watered down to fit the budget, and the idea gets to be exactly what it was imagined to be in the first place. The second aspect we want to accelerate is the truth a program runs on, the base of collaboration, a functional digital twin. Every department in every vehicle program working together on a continuously updated digital twin. One place, always current, always ready. Inside this digital control model in VRED, there's mechanical behavior, decision-grade materials, real-time accurate lighting, full configuration-grade variant logic, high-quality surfaces, as we just saw, and of course, PDM-PLM-derived engineering data. Converging into one source of truth that every department contributes to, collaborates on, and takes their decisions from. Variants 2.0 managed this at OEM scale. Cascading hierarchies, for example, to be able to represent the complexity of your vehicles, for example, for regionality, the steering side, so on and so forth, so dependencies between variants. Then we introduced different ways or different types of variants. Name-based, as you know it from VRED traditionally, but then also ID-based for unique identification, or even more exciting, metadata-based variants to keep your source data intact. So scene structure stays untouched while you still have the possibility to build complex variation on your model. If you ever assembled a complex digital control model and then had to rebuild the variants just because the data updated and broke the structure, this project is going to end this story for you. Real-time physics lets teams validate how parts move, collide, and behave. Opening a hood, swinging a door, checking hardpoint clearance or reachability studies inside the same digital prototype. In the future, physics constraints will enable this extend this with hinges, joints, and mechanical dependencies, turning the functional twin into a true mechanical prototype. Moved and interacted with based on physical correct calculation. It replaces friction and confusion with one model. Decisions made together early in the process in the same room based on the same truth. But of course, VRED, it's beyond functional. That's the new part. The traditional part where VRED is coming from is visual validation. And of course, we are strengthening that area as well. I brought an example today from Munich Group, where they connected Dynamo, Alias, and VRED through live referencing. And VRED is rendering the physical accurate reflection and refraction behavior in real time, while Dynamo is parametrically updating the shape of the light guide. So the light signature and the light distribution pattern can be tweaked and refined immediately. Any use case where physical accurate behavior or optical behavior matters now happens during design and not downstream in a specialist queue. And the same model carries forward into engineering for mechanical validation, cubing, ergonomics, reachability, you name it, into manufacturing for assembly planning and training, into marketing, where the same data drives the launch story and imagery. No separate rebuild, no parallel pipeline. When change happens, this twin updates everywhere at once. It's the one truth that is always ready, whatever the program asks for next. And the third area we're accelerating is the moment everybody needs to come together, even if they physically can't. But it's not just about bringing people together. It is also about giving everybody the means to contribute effectively. Some by speaking, some by deciding and documenting, some by evaluating, some by creating or changing, all in the same space, all in real time. And VRED Collaborative Design Review is built for exactly this reality. And we're extending it even further. In a single thread session, executive groups could join from their facilities, from their design facilities or Powerwall, while a design team, like in this example, the Kia team joins through VR and XR. For example, in this case, through a recently released app for the Apple Vision Pro, which is available for free to download for you, and you can also experience it down in the exhibition area, which is called Immersive for VRED. That technology combination, or that technology combines the visual quality and the placement and tracking accuracy that the automotive review demands, streamed from a local workstation or from the cloud. Other stakeholders might join from other devices, like phones, tablets, or the web stream, all in the same synchronized virtual scene. Every stakeholder has a first-row seat, regardless of skill, hardware, location, or technological setup. And when design questions arise mid-review, designers don't take an action item. They answer it live. They mark down onto a 3D exterior model, or sketch a curve, or modify an interior detail. The question is answered before the meeting ends. Every change will be synchronized across thread collaboration, geometry updates, annotations, material changes, and variants. Every participant, every modality, every device sees the same new version in seconds. And the rest of the team has the information that is captured during the meeting as soon as it ends through flow production tracking. And we are working, as we just heard, on a fundamental shift for this room with no walls, which gives every voice the power to act, Autodesk Assistant. When it lands in thread, you'll speak to it or you'll type to it. Outside the review, as Brandon already said, it's automating the work that is filling your tasks today that you're not super eager to do or has taken up a lot of time, driven by natural language. Inside the review, it's even more interesting because voice commands will be able to switch variants, navigate the model, or let you annotate or do changes. The assistant translates intent into action. Technical fluency stops being the price of admission, and every voice becomes equally powerful. This same room serves every part of the program. The truth, in the future, this room has no walls, no travel, no distance, no technology gap. But where does this go? Towards a future where visualization stops being something a team prepares and becomes something the entire program lives in. Continuous, always available, and decision-grade. Design teams pitching or reviewing, engineering teams evaluating, marketers showcase, leaders walk through decisions before they take them. AI executes without delay, and tools accelerate without limits. And humans bring what only humans can: vision, taste, and judgment. And, what is very important, the courage to push an idea through if they are convinced about it. Every step of a vehicle program touches the visualization layer. And at every step today, there's its own friction, its own weights, its own walls, its own limits. We are trying to dissolve those walls, break those limits, and accelerate every moment, large or small. And that is how we drive speed together.
How can we help you to leverage the value that is in your data? How can we accelerate processes and connect different teams and disciplines through the data? We can use predictive AI to connect to engineering and enable early insights in the design process. We can also add generative AI to recommend new shapes that optimize the performance but stay true to the original design intent. And we should highlight the fact that a studio's most valuable asset is not only the final surface or the final visualization. It's all the knowledge, all the workflows, and all the experience that leads to this final state. But step by step, with the goal to reduce friction and enhance collaboration between engineering and design, we provide you with the latest deep learning technology that enables you to extract valuable information out of simulation data sets and store them in an AI model, which enables you to predict simulation-like results within seconds in your design process. This technology is also available in Alias, so you can use NURBS models, sub-D models, or hybrid models as an input for the AI model. And whenever you want to evaluate the impact of a shape change on the performance of the vehicle, like we did here with the leading edge of the hood, you perform just a few steps. First of all, you open the NavPack Design plugin, you box select all your geometries, you hit the predict button, and whenever the prediction is ready, you first evaluate whether you can trust this prediction or not. If the check is positive, you review the performance of your vehicle, and after that, you can go back to modeling NURBS hybrid meshes. Since this technology is data-driven, it can be applied to more applications beyond aerodynamic. And with the latest update, we provide you with updated templates that help you to connect to more disciplines, help you to really scale to higher resolutions, larger data sets, and provide you with a best-in-class trustworthiness predictions, because you need to keep in mind, you will always get a prediction for a result, but knowing whether to trust those results, that's the holy grail of machine learning. When I look at this new truck, it looks amazing if you visualize it in VRED. However, I need to admit that the aerodynamic performance is not optimal yet. So this needs some further refinements. So we need to refine or optimize from our baseline model to a more optimized model. And this is something where our AI recommendation system can help. So let's break this down. Our AI recommendation system generates unlimited new geometries that still preserve the original design intent. Each of those geometries can be evaluated from the predictive AI model. So coupled to an optimizer, you can really step-by-step improve the performance and, for example, reduce the drag value. If we talk about engineering optimizations, AI recommendations, I think we really need to talk about surface representations. Since all those technologies, they work on meshes. So if we break that down, we start in Alias on a sub-D cage. This gets exported into a mesh, and this is where all those deformations and variations take place. Now we can also provide the functionality to synchronize those mesh deformations with the sub-D cage, so that the underlying target surface exactly matches what was recommended from the AI optimization. If we think in this structure, starting on a sub-D cage, moving into meshes, and applying the deformation back to a sub-D, you can imagine that you can also apply the same workflow, the same functionality, for example, to clay modeling, where you export a mesh, you mill it, you modify it, you scan it back, and then again, you apply the deformation back to the original sub-D cage. Additionally, you saw in Timo's talk that Form Explorer also offers powerful image-to-mesh capabilities. So this also fits into the same workflow. You can go back to a sub-D from your ideation in meshes. Before I want to widen up the communication to the broader studio knowledge, I want to circle back to Brandon's example about NURBS modeling. What we saw in this example was that we started from an initial state where we saw a non-finished surface. And we reached a final state where we optimized G2 continuity while preserving G0 and G1, even though this was a trimmed surface, which is quite a task. Now, imagine if you start outputting and collecting initial states, final states, and the way how you got from the initial state to the final state, and extending that concept to the most important use cases that you have in a studio. And in combination with the democratization of our APIs and the introduction of Autodesk Assistant, this really lays down a structural foundation for a world where you can really use your own data to train and fine-tune your own models, bake in your own experience, and make it available at the right time to the right people. And this is really a combination that unlocks a more agentic future. So when I envision a future example, it could look a bit like this. Imagine in your studio you've done more than 100 bumpers. You've done 100 fenders. You had lots of discussions on how to manufacture those parts and where and especially how to design the gaps between the parts. And now imagine that the next step, the execution, is really done based on that knowledge. Because in the initial state, none of that knowledge was present in the model yet. So the execution is not only automated, it's really enforced with your best practice that is based on your own data to get from an initial state to a final state. So, again, independent of how you come from an initial state and get to a final state, if you do it manually, if you use optimization algorithms, if you use deep learning, I really want to highlight and see this as a starting point of a discussion together on how we can help you to leverage the value that is in your data. Thank you.
So, we've heard a lot about data today, and let's be clear. Data's the foundation. None of the speed we've talked about is sustainable without having in the background the governance, a trusted process, and secure data. When we integrate all of these capabilities, whether it's custom models, automations, and connecting platforms, we're equally investing in governance, trust, and security. Because speed without trust is risk. And speed without process breaks down at scale. Our vision is not just faster tools. It's a trusted, governed, and secure design platform that allow you to really accelerate with confidence. So what you've seen today is not just a collection of features. It's a connected system designed around one outcome, helping you significantly accelerate your vehicle development process. Let me quickly just highlight a few of the things we saw today. There was Timo in the beginning, talking about AI-accelerated concept exploration, really getting from sketch to editable sub-D geometry in minutes instead of hours. This really compresses that part of the process massively. Then we heard Brandon talk about hybrid modeling and NURBS and sub-D integration, having always production-ready data, and make sure that designers can stay creative longer without paying for that at a later stage. Then we heard Lucas talking about visualization as a decision accelerator. We saw cinematic visuals, we saw functional twins, and we saw immersive collaboration. When stakeholders can see, evaluate, and interact earlier, decisions happen faster. Automation through APIs and Autodesk Assistant was probably the biggest thing we saw today. We showed examples of how data preparation is automated, natural language-driven workflows are executed in the moment you need it. This is more than just scripting. It's about democratizing automation for everyone, no matter if it's data management, data prep, custom workflows, agentic or assistant-driven interactions with the scene, with the things you're working on. Time previously spent on working on repetitive tasks is now redirected towards what matters most, design. Then we heard, obviously, Jakob talking about engineering insights in the design studio. With integrated simulation insights, designers gain earlier feedback directly inside their environment. That means Finally, stronger alignment between design and engineering departments. And the confidence here eliminates costly back and forth at later stages. But let us also take a step back, look at everything we saw, the bigger picture. What ties all of this together is the Autodesk Design Studio approach, a connected workflow from concept to engineering-ready outcomes. And this is all in parallel. It's not sequential. We add AI where it really adds value. It's about hybrid modeling as a differentiator. It's about automation that empowers every user. So when you combine all of these capabilities, the impact is clear. Shorter development cycles, higher design quality, earlier validation, and fewer late changes. So if your goal is to significantly accelerate your process while maintaining control and maintaining quality, the Autodesk Design Studio solution is your enabler. And with that, I want to thank you for today's session, for being here. Any questions you might have, the team, myself, we're going to be around for the next days. So really look forward to engage in the conversations and really shape this future together. Thank you very much.